a combination. Okay, you would like to. Okay, you come here.
Front
Come
sir.
here.
Here. Yes. Only one is allowed to do that. And the rest people will come. Listen. FEDS consists fundamental of electronics and digital system, right?
Yes,
So
sir.
you will have to go through some digital experiment too, right? So we have done one experiment from analog part. So we can do one from digital part as well, right?
Yes, sir.
So we might go one experiment from digital part today. What my point? Do you understand what I'm saying?
Yes, sir.
This course is the combination of both analog and digital, right? So we have done one experiment which was about measuring current and voltage, or like that, and resistance. This time we can combine both, one from an analog, another from digital. So this will make ourselves like clear about the course, total course. So listen, we can go through. Digital electronics starts with it deals with digits. Digits like what? Digital numbers, 0, 1.
Yes, sir.
Okay, so basically okay, let's say okay, this is the IC. So we'll work on this today. So the IC has got different names, like, okay, it's IC, integrated chips, but for each and every operation the IC is different. For example, today we have different logic operations. Do you know that? There is AND, there is OR, right? There is NOT. So these are the different things we have learned so far. So today we'll verify all of them practically, and we would like to see how it works. Okay, so we'll know the characteristics of AND gate characteristics experiment. Okay, you understand that? AND gate characteristics experiment is the first experiment of the digital system. We have done the first of analog system, which was measuring voltage and current. So this time, the first of that. Okay, so let us get introduced to this first. This is called IC. This is also made of semiconductor. Okay, and what is there inside the IC? For AND gate, this IC exactly looks like this. You'll see that the IC looks like this. So there is a notch. This is called notch. This is a portion. There is a small portion. You would see that there is a portion. There is a notch, what we know as khat in Bangla. So this notch exactly will tell you the number of pins. So this IC has got 14 pins, and every IC has got a number for identification number. Maybe for AND gate we are using 7408 IC. Exactly, if you look at this IC, I'll give ICs, right? So I mean, there are some ICs over there. I'll give you some, but listen to me first, and then we'll have a look on that. Okay, where? So come here. Come here. Listen, every IC has got 14 pins. So it is like this: 1, 2, 3, 4, 5, 6, 7. Okay, let me do it again. 1, 2, 3, 4, 5, 6, 7, and 1, 8, 9, 10, 11, 12, 13, 14. So each IC has got 14 pins. So we will use different ICs, but each of them will have 14 pins, 14 legs. Okay. And IC number, there are different IC numbers for different gates, different logic operators. For OR there is another number, but they look for same. Every IC, let's see, there are 3 different IC. Can you see in the board? This one, and if I add this one, this will be 3. Can you see there are 3 different ICs?
Yes.
Each IC look for same, but their operation or the way they function is different. So every IC has got a number like this: 74LS08, maybe another number K. So it is written like this. In every IC there is a numbers like this, but we find IC number only with the numeric. This is the combination of alphabet and numeric numbers, right? So alphabet is LS, K. These 3 digits are alphabet. So these alphabet will be avoided because this is exactly approaching the manufacturer's identity. So we do not need which manufacturer are producing this IC. We need what characteristics it carries out, right? What type of IC is this? So that will tell you with these numbers, only numeric values, which is 7408. So any IC would have will be in the name they have the combination of numeric and alphabet. So you will always avoid the alphabet. If you go somewhere in the old Dhaka or some Nawabpur and ask for an IC that give me AND gate IC, they would not understand that. That people will never understand what AND gate means, but they would understand the numbers. If you ask for them, give me 7408 IC, they will understand that. Listen, those who are staying back, still working maybe on a report, I'm telling you what, the thing I'm delivering will be, your exam will be based on this. Because the information is given, the question will be based on that. So do not pay attention to something else other than this. Come front. Listen. So now this notch, okay, so numbering of an IC is really easy, right? Just the numbers, numeric values. If it is an OR gate IC, then it would have been like this. There would have been 32. 7432. This time the number would have been 7432 IC. Stands for OR gate.
So is it the code for OR
Yeah.
gate or AND gate?
Every IC has got specific numbers, right? So with that number, we exactly find the electrical characteristics of that IC, that how it will behave, what is inside that. And if it is not gate, then it would have been 7404. So 7404 is not gate IC. So we will exactly learn about these 3 basic IC, because this is digital system, right? So digital system, any other than maybe NAND gate. Think about NAND, NAND, right? So NAND means not plus AND. So if you combine this AND and not, you will find NAND. So these 3 ICs is exactly the basic ICs by which you can make other NOR plus OR, NOR. So that is how you can make the other remaining combinations using these 3. You understand? So these are the basic thing.
And 740804 would be the non-NAND.
I have given the number. 7408 IC is for AND gate.
Then we have to add both toes or just last 2 digits.
Where?
If we make NAND and yes.
No, for NAND gate there are different ICs. NAND gate is 7400 IC, which stands for NAND gate, right? But listen, now we will look at what is
How
inside.
we can understand to which number is represent what?
Yeah, for each IC, if you go through the net, you will find. That is for everywhere, for the universe. 7408 is for AND gate. It is in the America, it is in the China, it is in the Korea. Wherever you move, you will find 7408 stands for AND gate, right? Now listen. For all manufacturers, they follow the code. This is the code exactly, the code number. Okay, listen. Now, what is inside this IC? This IC, listen, this IC has got a notch. If you look at the IC very closely from the front, you would see there is a kind of notch, very small, what we call khas, okay? So which looks like this. So this khas, or notch will tell you which, okay, normally with the there is no pin number, but pin number is always matters, because maybe pin number 7 will be connected to the ground, pin number 14 will be connected to the positive terminal of the battery. Now, how would you know that which pin number is pin 1 or which pin number is pin 2? There is no way of identifying this because it is very small and you can hardly see the pins. And there is no way, there is no number written over there, right? So they have left only this, notch to find you out which pin is pin number 1 and which pin is pin number 2. So pin number 1, there will always be left, this is what, left or right? Right to left, anti-clockwise. So if it is that pin number 1, notch, then this will be the pin number 1, to the right one. And then pin number 2 will be, and it will be gradually to the, so this will be pin number 14, and this is pin number 1. So how would you, there will be a question that how would you find that which pin stands for what number? So you have to then find out this notch, and then, okay, now connect the pin number 7 with, ground of the power supply. Then how would you do that? You find, okay, you find this notch first, right? And then you will start counting this one as pin number 1, and this one will be pin number 7, and connect this to the ground. But if you somehow by mistake make this one pin number 1, then this would be pin number 7, but it is not going to work by that. Okay, now if it is an AND gate IC, right, then how it looks like, 7408 will be the number, and AND gate has got 2 inputs, right?
Yes, sir.
And 1 output, like this. So these 2 inputs and 1, so there are 4 different gates inside this IC. How? Let's see, pin number 1 and 2, they have got 2 inputs, like this. Pin number 3, 4, another 2 inputs, and 6 is the output. Sorry, pin number 3 is the output. So pin number 3 stands for on AND gate output. So this is the output, right?
Yes, sir.
And this is input. Input 1 and input 2. So input 1, input 2, and the output. So let's say pin number 1 and 2 is input, and 3 is output. Again, pin number 4, 5 inputs, 6 outputs. Similarly, this way. Pin number, this is pin number, this would be like this. Pin number 8, 9, 10. The number will be a sequence. Okay. Again, pin number 13 and 12 input. 11 is output. Now, for AND gate, so this is how 7408 IC looks like inside. There are 4 different gates, right? To verify AND gate characteristics, how many gates we require? Only 1 gate, because we will give some input, maybe 0, 0, then 0, 1, 1, 0, and 1, 1, and we'll verify what is the output, right? What makes 0? Then 0, 1 makes what?
0, sir.
Have you gone through the truth table?
Yes, sir.
Okay, it was 0, 0, 1, 1, then 0, 1, 0, 1. So this was input 1, A or B, right?
Yes, sir.
And output. Output was 0, 0 for 0.
Yes, sir.
0, 1 makes
0.
0. 1, 0 makes
0.
0. And 1, 1 makes 1. That's what we have learned. We haven't seen it practically. But now our job is to see this practically. Then why exactly it is true or not. Experiment is like something you see practically. You do not believe others. Okay, let's see. So do you have any question regarding this?
No.
Now every IC is similar. If it would be an OR gate IC, just the gate would have been OR. The other thing is same.
So what
Got
about
it?
14?
Okay, I'm telling about that. Now Pin 7 is okay. Now power providing. Okay, so these 8 pins, 12 pins used for gates. Only remaining 2 pins, right? 7 and 14. Okay, this IC needs power, right? Without 5-volt power, it is using 5-volt power. So without power, this IC is not going to work. So there is a battery. This is the power supply. So battery positive terminal, which is a 5-volt battery, and negative terminal, right? So this negative terminal will be connected, which means ground. Negative means ground. Ground will be connected always at pin number 7, and this positive 5-volt will be connected for pin number 14. So this is the circuit exactly. This is the experiment circuit. Okay?
Of AND gate.
Of AND gate. Today's experiment is AND gate characteristics. Verification of AND gate characteristics. And now our job is just what? To verify this AND gate. So we have 4 different AND gate. We need how many? Only 1 gate, right? So we can use up to this 1 to 3. Pin number 1 to 3. Pin number 1, 2 will be for input, and pin number 3 will be for output. You understand? Yes. Okay. And I will introduce you with a board by which we just verify these characteristics. Can you bring this board? This pen. Can you see there are some? Okay, I'm showing you. Okay, I'm showing you. Wait. Let me carry these things. Can you hold it this way? For everybody. This way. You come. Hold it. Listen. Look at this. These are different logic switches. Right? These are called logic switches. Okay? Once you push it up, it makes 1. And once you push it down, it makes 0. You understand? Yes. So that means if we push this switch up, then it is 1, and if you push it down, it is 0. Okay, let us connect pin number 1 and pin number 2 with 2 different logic switches. Right? Once we push this logic switch up, then it will be 1, and once we push it down, it will be 0, right? So that is how we can give different inputs. Either it is 0, 0, 1, or 0, 0, that means both logic switches will be pushed down, right? And then 0, 1, that means 1. This will be pushed down, this will be pushed up. So you really understand, right? What is there? Now output. Listen, to verify the output, we have different LED lights. If LED light, if there is 1 at the output, this LED light will be switched on. It will make light. Any of them.
Any of them will.
These are all for outputs. So for now we have only 1 output, so we will use only 1 LED, right? One of them. So if we would like to use this one, we have to connect it here, right? So if there is 1, this light will be on. If there is 0, the light will be off. You understand?
Yes.
Okay, so put it here. Now listen, what is going to happen? We'll place this one to a LED light, right?
Yes, sir.
Got it? We'd like to push this to a LED light. Now, if we are okay, what's going? How will we verify things? Listen. First, we will press. Okay, let's do this. 0, 0. Both will be switched. Both switches will be down. So that makes 0, 0. At the output, it is 0, right? Yes, so this LED light will not be on. It will remain off. Again, next 0, 1. So this will be pushed down. This will be pushed up.
Yes.
That makes 0. Again, light will remain off. Then 1, 0. Again, light will be remaining off. And finally, when I press 1, 1, the light will be on. Right? Okay, listen. Where these gates are applicable, right? Your computer arithmetic logic units made up with this thing. Suppose how computer add these 2 numbers. 1 and makes 1, 0, right? 1 plus 1, what is that?
1, 0.
1, 0. How it is made up? Listen, adder circuit. There is an XOR and an AND gate. These 2 together makes this one stands for carry and this one stands for sum. So if we give 1 and 1 as input, right? So carry will be 1, sum will be 0. So this light for AND gate will switch on and this will be switched off. So that is how your arithmetic logic unit of computer is made of, calculating parts. So AND gate is used there. There is one application of AND gate, right? There are others too. Actually, computer and all the system that is happening without human intervention is basically, I mean, what we call automatic system. It is based on this digital. Okay, let's see one more example. Have you seen in the garments factory, there are tray. The tray is automatically running, right? So maybe it's a garments industry. What is this called? I mean, blazer. This blazer will be made of. So somewhere the blazer sleeves are made, somewhere collars are made, somewhere these buttons are connected, right? So, okay, think about, okay. Can I erase this?
Yes, sir.
So let's look. It takes time because it's a first class, right? Maybe this is the tray. This tray will move here. This is the portion where collar made. Okay? Collar made up. This is the portion where bottom are connected. This is the portion where other thing is done, right? So that means a straight line. Here I have made collecting the collars, and after a few that sleeves connected, right? So once the system will be developed such a way that once I am taking all the clothes here, if there is no clothes over the tray will stand here. And once I am putting the clothes after completion of my job, once I am putting the clothes over the tray will run automatically. And at the other end, when it will reach here, tray will keep going. When it will reach at this end, that person will take all these clothes for next processing, and until he finished, that tray will stand there. And once he finished, he will put all the clothes again over the tray will again is automatically will run to the next terminal. It can be done with simply this AND gate. Just only one AND gate can make it. Okay, let's see how. Think about this tray. The tray made up like this. There are two wheel, and there is a, listen, there is a kind of motor. If that motor gets power, there is a belt from the motor to the wheel. The motor runs, the belt moves, the wheel will move, right? That is the system of a tray. Now connect an AND gate with this motor. So motor will only run when motor will have power. When power is delivered to the motor will run, right? What we see, if we switch it on, power is delivered to the fan is moving. That is happening, right? So that the same thing will happen here. Once you can make it very easy. So one input of the AND gate will provide with one always. The other end will be connected here this way with this is exactly the tray, and this is another portion, and this portion is separated with a spring. So if it is there, if there is no weight over there, with the force of spring it will be up, right? So it will be then 0, and once it is touching this portion, it will become 1. So when this becomes 1, this is connected with this. When this portion becomes 1, and this is already 1, 1 makes output 1. That means it will allow the current to pass to the motor. And motor will run. So when I will put some clothes over there, with the weight of the clothes, it will get down. It will make this portion 1, and this portion is already 1, right? So that makes, do you understand?
Yes, sir.
That makes the motor running and tray will run. And at the other terminal, when people other people will take up the clothes, this will come up because of the spring, and it will become 0, right? So 0, 1 makes 0. That doesn't make the motor running, and it will stand there. And once he finished his job and put the clothes over there, it will again run the similar way. So see, with using this logic, all the things are running without human touch. Do you understand? So now can you make it? And you will very much understand for now that how this automatic tray is running. So that is why you need to learn this digital system. to interpret the automatic control system. Do you understand?
Yes.
Okay, that's it. So we will now conduct this experiment.